The next one, write a variable normally distributed with the mean 70, elevation 7. On the following diagram, shaded the region representing x greater than equal to 55 and smaller than equal to 75. And find it. Okay, for this one, I believe you can do it yourself.
Okay.
After finishing this one, we can move on to the medium question.
All right.
$55 to $75. Mean 70, elevation 7, 75. Norm CD, yes. You should write that prop of writing this one. The prop of x greater than 55 equal to that, smaller than equal to 75 equal to this normal CD. The lower value is 55, the upper value is 75, and then distribution normal, CD variable, lower 55, upper 75, standard deviation 7, and mean 70. And
on the 0.746.
Yeah, exactly.
All right, I'm gonna try C also now.
Oh, by the way,
yes.
Look at the value on this calculator. The Z value here, low and up. The lower value is equivalent to 55 if you standardize this normal distribution. Standardize, meaning the mean is now 0. The value 55 there will become minus 2.14, minus 2.14, and the upper value 75 is equivalent to 0.714, because we can calculate this one by taking the value 75, subtract the mean 70, and divide the standard deviation 7. Okay.
Yeah.
Check that.
Do we have to like standardize?
Sometimes later, when doing the medium question, even the hard question, you need to sometimes depend on the type of questions. 75 subtract 70 the mean, and then divide 7. There, 0.714. Okay. And similarly, 55, you subtract the mean 70 and then divide the standard deviation to be 7, you will get minus 2.14. Okay. The calculator already do the conversion, standardize for us.
All right.
The next question, C, given that the prop of x greater than or equal to q is 15 by the value of q, inverse normal,
All right.
That is the right, because it's greater than q.
Yeah.
15%, for example, this area. Yeah, 15% area on the right. This is the value of q.
Oh, yeah.
The area is 15%, meaning 0.15.
Yes. And 77.3.
Yeah, it's correct. Okay, let's try a medium question. Let me move to that. You can do the other easy question yourself if you have time.
Okay.
Do the question medium 13 here. 13.
Right.
Let the random variable x be normally distributed with the mean 16. Is it possible that I can navigate by hitting my... Okay, I think I can do that. Click here. No. Okay, sorting. Mean 16, show the following diagram. The shaded region between 16 and 20 represent 35% distribution. Find the prop x greater than 20. Between 16 and 20, I wonder if that range include the value 20 or exclude it. Between, I think it exclude the value 20.
I think it also excludes.
Exclude, yeah, 20. Check the math scheme. I think it's simply just subtract 50% by that 35%. The answer is 15%. Wait, it's not this one. Yeah, just subtract 50% by 35%, huh? And the area on the right greater than 20 is 15%.
Right.
Okay. The question B, find the standard deviation of X. This is a question that we have to use the standardization method.
Oh.
Because there is no other way that we can find it using, such as using the inverse normal. Okay, we have the value 20 here. Let's assume the standard deviation is sigma. Okay, we have the value 20. Okay, we will standardize like this. The mean 16 now becomes 0. The value 20 had a z-score of 20, which is 20 minus 16 over the standard deviation sigma that we need to find. Okay, sigma here is what we need to find. And to find that, the standard deviation, we need to find the z-score here. The z-score 20 there is found using the inverse normal like this. Distribution, okay? Normal, yeah. Distribution, inverse normal. And now using the standardized normal distribution, the value z20 is found by putting, we know that the area here on the right here is 15%. Okay, we're going to use that, meaning in this inverse normal, we use the tail right, the area is 15 or 15. And the mean mu here is chosen to be 0, the middle here. Okay,
yes,
chosen to be 0, and the standard deviation must be chosen to be 1. Yeah, so that the inverse normal, the z-score 20 is 1.0364. Inverse normal, right? Okay, and 0.15, and standard deviation is 1. The mean is 0. Okay, and that equal to 1.04. 0364. 364, as many numbers as possible. 3. Okay, and then from the z here, using this equation, we can find the standard deviation. Okay, please do the rest yourself.
Okay,
because this one is equal to 20 minus 16, which is 4 over sigma. So sigma is found easily, huh?
Yeah.
So this example of why we need a standardized normal distribution, huh?
All right, got it. I got the sigma is got 0.259.
0.259.
Yeah.
Wait, that's weird. Sigma here is 20 minus 16, meaning 4. 4 divided by 1.0364. That is a little bit smaller than 4.
Yeah. Oh my god. Oh my god. No, I calculated wrong.
because you see that this area is 35%, approximately 34% in the normal distribution, 34%, meaning the value 20 there is about 1 standard deviation. And you see from the inverse normal, the value here there is a little bit greater than 1 standard deviation. The z-score here mean is equal to 1.036. It means the value 20 is 1.036 times greater than the mean. The difference, it means the difference between the 20 and the 16 value is 1.036 times the standard deviation.
All right. So sigma value I got is 3.86.
Okay. Okay, that example of the standardized normal distribution, huh? Later you see again.
All right.
That's we practice a lot, so then we eventually master it. Question 14. Question 14. That's weird. That's so short, huh? Variable x normal distributed with the mean 120. The standard deviation is 15 by the interquartile range of x. Okay. Interquartile range, the mean is Q2. The it's a Whittaker plot, huh? Lower quartile Q1, upper quartile Q3, and then a max and mean somewhere. Doesn't matter where the max and mean is, huh? But to find the lower quartile or upper quartile, the lower quartile here, the probability of finding the value from the lower quartile to negative infinite to the mean, is 25%. And similarly, the probability of finding the value greater than the upper quartile to the maximum is 25% also. Okay, it means that you will use the inverse normal to find the lower quartile and upper quartile like this. The inverse normal for the lower quartile, we use the left. Okay, left. The area is 25%, and the standard deviation is 15. The mean is 120. Okay, done. Here, this is lower quartile, 109.88. Let me check it with the answer first. Here, exactly. Okay, and similarly with the upper quartile. So please write the solution, huh?
All right.
I sit here. Lower quartile using the area on the left with the area to be 25%. Similarly, with the upper quartile, the area on the right, 25%. And the middle from Q1 to Q3 is 50% left, huh?
All right.
Lower quartile, you can write Q1 equal to inverse normal.
All right.
Left, 425, 15, 120, mean 120, and it's equal to
Q1 first.
Yeah, Q1 lower quartile.
So we can write like exactly like this on a test, and we still get marked for like showing like steps, right?
This writing is enough, yes. Inverse normal, left 425, yeah. And the value is 109.9. We can take only one significant figure, one decimal place. Okay, 0.9. Similarly, the upper quartile Q3 is the inverse normal of the right.
Got it.
Q3, huh? Now we change left to right, simply that. Right. And then execute. 130.1.
All right, done.
The question is the interquartile range. So we need to subtract Q1 from Q3. interquartile range IQR equal to 130.1 minus 109.8.9. Interquartile range